great sessions today. I really hope that you all have enjoyed the conference. People have done a lot of work to put it on, and as Mark mentioned, make sure you stop by the sponsors tables. These events aren't possible without those sponsors, so we don't have a specific sponsor slide. So I'm going to tell you right up front right now, I'm using a Windows box, I'm using PowerPoint, and I'm going to show you a demo of SQL Server. And I'm at an open source conference. If this bugs you greatly, you're welcome to walk out. Or you could say, Pat's also learned about open source and he's been a convert to other things, and so we should really hear what he has to say, because a lot of people have to go through things that I'm going to talk about today. So, and in my session today, and I'll bring up about me, and if you want to go ahead and QR code the scanner, that's the joined in link, or you can just use the link there. 13919 is my number. I love feedback. Speaking is difficult, and the more feedback you give me, the better I get at it. For my talk today, I'm going to have two basic audiences. I'm going to have the people that are just trying to get started integrating into a Hadoop or a big data platform. The other people I'm going to have is the people that really want to know how we did it, because everything I'm going to show you is something we did over the last year and a half in my company. I can tell you horror stories. I can talk about the things that worked and that didn't work. I love to have conversations with my audience. So do not at any time feel like you can't raise your hand. I've been in tons of sessions today at open source and you're all way too quiet. I would love for you to argue with me. I would love for you to ask questions. Please ask me those questions, okay? So, about me in general, I hate to talk about myself. I've worked with data for about 15 years. This slide's a little old. I do a lot of things in the community too. If you've heard of Utah Geek Events, I run Utah Geek Events and I put on those events. Happy to talk about those after. Right now we're going to talk about data. So the things that we're going to talk about today are really about how we started integrating relational databases with Hadoop. Okay, and we did it with SQL Server, but everything I show you, I'll talk about MySQL, Oracle, Postgres, like the previous session. Any of those things all benefit the exact same way. Okay, we're going to talk about the problem that I had, and then what solution we found, and some of the different things we tried. And this is, again, I love debate. I love people asking me questions. Feel free to do so. I'll show you a demo at the end so that you can get started. I'm all about the 90 days proof of concept. If you can get 90 days proof of concept and show people what the value of big data is, you can make a difference in your company. Okay? All right, so this is by far my favorite quote about big data. I'm not big on reading my slides, but I do have to read this one because I love it so much. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they are doing it. Now, this is a little bit older. This is about a year and a half old, but it's still true to this day. I help manage Big Data Utah. I help manage the Utah Hadoop Users Group, and trust me, it's still true to this day. Okay? People still say it. What is big data? Who wants to answer this besides the message I put up there? Besides the V's? Anybody? See, way too quiet of an audience. I'm going to get you to speak up. Yes? Document everything, okay, that's a great way to define it.
Tons of data, and you don't know what to do with it.
Keep everything, analyze later. Yeah. That is a wonderful way of putting it too. I love when people tell me that. Keep everything, analyze it in the future. Great use for big data. Big data to me is anything that solves a problem with data. Okay, now that may sound wrong because people say, well, big data has to be petabytes, it has to be exabytes, it has to be a lot of data. No, it doesn't. My entire system doesn't have more than 2 terabytes of data in it. And I have a Hadoop cluster. I have one of the largest ElasticSearch clusters around, and I still use those big data platforms. It doesn't have to be about the size of your data. It doesn't even have to be about how many transactions it has. It has to be about you solving a problem. We solved a scalability and cost problem. That's why we used big data. Okay? So, and I love to tell people that big data is not new. It is a terrible, terrible marketing term that someone came up with. 1980, there was a 1.44 floppy disk. Actually, it was 90. That was big data. You couldn't fit a Word document on it, you know? That's big data. That's a problem with data. Now, it's the same thing. We still have the same problems. We're just trying to fix them with different tools. So please don't think that big data is the newest, coolest, greatest thing out there. You just have new tools to play with stuff, okay? All right, a little bit about my company, just so you know what my problem is, you know what we were doing. We're Merit CX. One quick plug, we're hiring. If you want to talk about that, please come see me. We do voice of the customer intelligence. We help you to have happier customers. We take surveys, we take questions, we take all this data that our customers give us to produce reports to say, your customer was upset about their experience because of this reason. We do that so that we can help you have better customers. Okay? We're a SaaS platform. Everything we do is basically online. You go to a website, you fill out the survey information, you take it back. Okay? And a lot of our customers give us more of their data so they can analyze it along with the responses. All right. The problem we had was a very common problem for many people. We had slow site performance. Excuse me. We had a classic ASP site. We queried our database directly. We made a really cool query search form where you could add more filters. And the more filters you add, the bigger the SQL stored procedure got. Yay. Let's just find more ways to slow down our system. So we had the classic OLTP system with read and writes all going on at the same time. Way too many indexes, and that's partly my problem. Way too many indexes, but that's what you have. You have that issue of reading and writing in the same place. So you talk about solutions. What do you do to get your reads and writes separated out? What are some of the technologies you use? I'll show you the current architecture, and then we'll talk about those options that you have. Very simple, basic picture here. We had data coming in. We had SQL Server. Again, if you want to replace that with MySQL, Oracle, Postgres, whatever you want, it's the same thing. And then you had a service query in it, and you had a website. This was slow, would produce queries of 300 seconds. You know, people would be waiting for reports for 5 minutes, 10 minutes, all of those sort of things. Again, the classic thing that you run into. So what are some people's favorite options to get away from this? What are some of the things out there, the technologies or things you use to get away from reading and writing from the same store? Oh, I still can't wake up the audience. Memcache, okay, so a caching layer. So the point here was a caching layer, right? That's a great idea. Move the data into a memory cache, and then you don't have to query it from the slow database disk performance. Excellent idea. Did I see another hand? Replication. That's another great one, and we'll talk about that one first. So Memcache is a great idea. Replication, yes?
Restructure your database for the queries versus data.
Okay, so restructure your data for read queries instead of for write queries. Move out of normalized form and separate it out into a more what's the word I'm looking for? Denormalized form. That's it. So yes, that's an option too. Okay, replication. Replication is one of the options we tried. First of all, if anybody knows SQL Server, they've got crappy replication. Quite frankly, it just sucks. MySQL, wonderful replication, but SQL Server, crappy replication. So replication is an option, and we did the same idea. We not only did replication, we did the idea of taking the data out of a normalized form and putting it into a denormalized form. A custom script that ran. Now, what are some of the faults of doing either one of those? Bueller. I like to do that. Okay, some of the faults. One, takes time. Yes, you can get it down to per minute. You can get it down to 5 minutes. If you buy a lot of hardware, if you can do that, that's one option. But you still have a batch system. No matter how you look at it, it's going to take you more time. Two, you're duplicating your data. There's another piece of it somewhere else. Now, my solution that I'm talking about will be duplicating it as well, but you may have a lot more cost. In our case, you would have a whole other SQL Server over there, which for us was a licensing cost nightmare. Okay? If you're talking about a MySQL or something, you still have hardware and SQL Server and maintenance costs that are going on there. So you have all those different options. So replication is an option, a viable option, but those are the cons to them. There's always pros and cons. Another option that you can choose for is something like cubes. SQL Server has a really good analysis services cubes out there. MySQL has pre-processing options as well, so does Oracle, and so do the other technologies. This is basically a pre-processing option. The pre-processing option, the cons are, one, takes a long time. Typically, a cube sort of structure can take anywhere from like 8 hours to 24 hours sometimes. We actually did this as well. For one customer for us, this took 14 hours after we gave it a whole lot of hardware. And I mean a lot of hardware. Fusion IO drives, and it still took that long. So there was many different things that can be done like that. Pre-processing is an option, but with pre-processing, you always slow down what you're doing. Okay? So where we ended up, here's the platform we ended up on. And what I'm going to do is I'm going to show this slide. I'm going to talk about it briefly. Then I'm going to go into demo, and then we can come back to this, because this is where 90% of my questions come in. People want to know why I chose the technologies we did and what we did, and I will do that. But I want to make sure if there's people in the audience that are new to it, I show the demo on what you can do to get started. Okay? So basically, we took our transactional relational database, we moved the data over with sqoop into a Hive table, and then we pushed it through into Elasticsearch. Now, in big data technologies, you always hear batch layer, processing layer, speed layer, these sort of things. Our batch layer was essentially Hive HDFS system. Our speed layer is Elasticsearch. You can query very quickly across Elasticsearch. You can do millisecond queries. So that was our choice on Elasticsearch. Hive, in my opinion, this is my opinion, is the best batch processing cheap data store system out there right now. It's the most stable, has the most information about it. It's absolutely a great batch processor, and it's dirt cheap for 20 terabytes of space. My Hadoop cluster right now has 20 terabytes of space. I don't think it cost me over $15,000. I mean, and that's expensive, in my opinion. You could go much cheaper than that. So those are the main technologies we used. Let me go ahead and show the demo really quick, and then we can come back to this and start asking more questions about some of the different things that we did. I'll go back to those. So I have nothing more than a simple Oracle VirtualBox up here running. This is Hortonworks Sandbox 2.0. I can't say enough good things about Hortonworks Sandbox. If you are getting into big data and you are doing these things, the Cloudera Sandbox or the Hortonworks one, I'm preferential to Hortonworks, is by far the quickest and easiest way to do this. This is a 20-minute process to get this little guy running. Well, it's just for the download. Get him running, and then you can play all you want with him. And this is excellent. So if you are getting into it, I can't suggest this enough to go and use these. So what I'm going to do is, as I said, if you're adverse to SQL Server, please avert your eyes. I've got a simple table inside SQL Server. So on my system, I had an ETL process that actually ran through SQL Server, created the tables I needed to move over. Now, a lot of people ask me, why didn't I move all my tables over that I had normalized in the database over into Hive? Because I didn't need to do tons of extra joins inside Hive. So how many people here believe that Hive is a fast way to process data? Okay, you either just don't know or you're not raising your hand. It's not. The next time someone says, I'm going to remove my relational database and move to Hive because it's got fast queries, please slap them. Okay? Hive is not quick. It is a large batch processing system. The difference with Hive is that you can put petabytes behind it and it'll never fail. It'll just keep running. It may never return, but it'll just keep running. Okay? So Hive is very, very good at processing large amounts of data, but please don't think that it could run a query faster than this in SQL Server or in MySQL or in Oracle. Trust me, hands down, Hive will lose every time. Okay? So I've taken this data, I've put it into a table. This is just a little table of baseball data, basically. That's what's inside here. This is a simple database of all the different stats for baseball players. I stole it off the web. So that table's there. It's inside SQL Server. I'm going to open up a putty session, and we'll go into Hive. I'm pretty sure I've got to delete the database, so let me get this so everybody can see. Now, the other thing I'm going to mention here is if you're new to Hive, this thing is like horrible on the verbose statements. I mean, Hive is annoying as hell. So is Hadoop. Their logs, they're huge. The reason Logstash exists is because Hive spits out everything. So trust me when I say you're going to get a lot of stuff back from them. So, but Hive basically gives you simple, I'm going to have to zoom in every once in a while. So it gives you simple databases and tables inside Hive. That's what Hive really is doing. When you query a table inside Hive, you're doing a map-reduce job behind the scenes because Hive lives on HDFS, which is a distributed file system. So it takes all your data, distributes it across many nodes, and then queries it back for you. This is why it's not faster than a standard join inside SQL Server or something else, because it has to go and pull that data all back together, map, reduce, okay? So I've got a database here called default. I'll go into default. And trust me, if you're a SQL person, MySQL, anything else, well, MySQL is fine. I can't get used to semicolons. I have a really hard time with it. So please forgive me for that. I'm seeing if I have my table here. Okay, so my table is there, SQL Saturday move table. It's already there. So I'm just going to drop it for our demo so that we can not dorp it, drop it. Didn't we say we shouldn't type in demos? And you can see that these are very simple standard SQL statements. I mean, this is nothing terrible. If you're used to MySQL, Oracle, SQL Server, this is easy. This is not bad. The reason I suggest that people start with Hive is because it's very similar to SQL in its commands. And so you get used to it very quickly. Okay, now I've gotten rid of my table. All right, I'm going to exit out of here. And then we'll go into the sqoop command. And I'll walk through the sqoop command so that we can all see exactly what it's going to do. Sqoop means SQL to Hadoop. Okay, so basically this is your query tool to get from SQL Server to Hadoop, or Oracle, Postgres, MySQL, anyone else. Right here, you basically have the different commands. Verbose, it gets worse than what I showed you earlier. You can literally make it do more. If you're running a production command, don't put verbose on it. Okay? It's fine for testing, but seriously. Connect, simple connection string. For me, I'm using a JDBC driver. If you got to connect to SQL Server, you got to go pick up a JDBC driver. In this document, on my joined in profile, this document is there. So I give you the URL to the actual JDBC link if you need it. If you're on a MySQL box, it has a built-in command. You don't need to do this. Okay? Oracle, you'll need to get an Oracle driver. Postgres, need to get a Postgres driver, so forth and so on. So sqoop tells you, this is where I'm connecting to. Again, very simple, database, all the stuff you normally see on a connect statement. Nothing rocket science here. What table you're trying to move, you want it to import it into Hive. Now, normally sqoop just says, I'm going to take your data and I'm going to put it on HDFS. That doesn't really do you any good. You need it in a table format because you're going to use SQL against it. So make sure you say Hive import, or else it will just end up as a file on your HDFS system and you won't know what to do with it, okay? So make sure you import it into Hive. It does give you options for incremental loads, which we use, but we actually provide our own statement to say what's the incremental. So it's really nice that Hive can look at a table and say, this has changed, send only over what's changed, if you give it the checking column and the incremental, okay? If you tell it this, it'll do it. Otherwise, it'll grab the entire table and move it over to the other side. Does that make sense to anybody? Or make sense to everybody? Okay, the other one, Hive drop import delims. Now this is probably, I don't need to mention in this session, because this little switch, the only way I could get this to connect and work with SQL Server was if I added that switch. But the documentation on sqoop really doesn't tell me what that switch says, or does. It's kind of strange. I haven't seen it needed on a MySQL system or an Oracle system, just SQL Server. So feel free to drop it off and try your system. If it works, great. If it doesn't, come and yell at me and I'll try to do something about it. All right, the most important parameter, and I will tell you this over and over again, -M1, okay? This is how many mappers sqoop will use to map your queries against your database. So when sqoop comes out and says, I'm going to grab this table that you told me to do, this SQL Saturday move table, it's going to do a query against that table just like any other SQL command, just like Oracle or anybody else. If you put map3, if you put M3, it'll do 3 queries. Those 3 queries will take your primary key, find out how many rows are in the table, and split it by 3. So you'll have 3 queries trying to pull your entire table all at one time. And I guarantee you, if you try this against a really large table, it will lock that table, period. Okay? I had people come back to me afterwards and say, we tested this on our Oracle database and we connected it to there, and the default is M3, and yes, it locked their table on their production system. I said, no, you have to do -M1, so you only have 1 mapper. Now, if this is a table that nobody else accesses, if you have made this table and there's no one else querying it, fine. You can turn it to 3. It's not a problem. But be aware that that's what it does. It writes 3 queries, and it tries to get all your data at once. Okay, if it's a very large table, it's going to lock the table. All right, so that's basically all of the sqoop import command. Now, I will say that the online documentation is there. It's, let's say, questionable. It's good. It's not great. Yeah. If you use this, again, this gets you to your 90-day proof of concept. If you steal my command down here, which again is sitting on joined in my zip file, it will greatly speed up what you need to do. Okay, this one's already written for you. Just copy and paste. Okay, questions on sqoop in general? No. Now, sqoop can do other things, but the whole goal and idea behind it is to get to SQL databases to pull data into Hive or Hadoop. Okay, that's really its purpose and design. If you use it for other things, that's fine, but really you don't have to. All right, so as you can see here, I've just basically given you the same command. I'm doing the same thing. I'm just going to run it in a session window. And again, we'll see way too much stuff coming back. This will take 20 or 30 seconds. It's on my VM, so it's going to take a minute to run. But all it's doing is taking the data and moving it across. And I'll show you, there it is. That's what I was looking for. So this is where I'm talking about the map and reduce phase. So when you have a job like this, it's putting the data onto HDFS and mapping and reducing it to put it into a Hive table. Okay? You want them in Hive tables. If you just put them on HDFS, they'll be even slower than a Hive table. So you want them in Hive tables. And then as you see it finishes, shows up that it's there. So now we can go back into Hive. And for anybody that doesn't like the command line interface, there is a GUI to this. The Oracle VirtualBox shows it to you right here. Say, hey, go to your browser, go to this page right here, which no one can see because I'm not zooming in on it. Okay, so show databases. I don't need to do that. I'll just do use default. And then I'll just do a select. Okay, so as I said, very similar to SQL statements. Nothing really rocket science here, but if I query that, then I should get back. Now I have my table in Hive. So from here, a lot of the times in the past in this presentation, I would go into Excel or something else and show you how to connect ODBC to it or connect something else to it. But once you get it to the Hive phase, basically you have the ability to use any front-end application you want to connect to it. And you have the power of, if this is a petabyte of data, the query will return. It's not going to return quickly, but it will return because that's what Hive is really good at. So some people ask me a lot, why did we bother doing this when we were just ending up in ElasticSearch anyways? Because we wanted to put our ETL process inside here. And the reason we did that is because we're batch processing data, and our ETL can now go faster and faster depending on how many Hadoop nodes we give it. So Hadoop scales out horizontally. And the more task slots you have, the more steps of your ETL process you can do at one time. So if I want to expand out my ETL process and make it take less time, I can buy more machines and expand that out. Does that make sense to everybody? Okay, so as I stated, we'll go back over here. I think I'm doing pretty good on time too, so this is where you really got to open up and ask questions because that's the most important thing. So I will tell you the reasons we went to this. The whole idea here is that it was highly scalable. Our Elasticsearch cluster is scalable, our Hadoop nodes are scalable. We now have a way to scale out horizontally. We don't have giant licensing costs from our relational database. We can scale out horizontally, okay? Less cost, and it's very quick when we talk about our Elasticsearch solution. So let me show that here. So as I just showed you, what I took was data from here. I used the same sqoop commands we just showed. It actually goes into Hadoop. If anybody says it doesn't really go into Hadoop, it does. It goes onto HDFS and then builds a Hive table for it. And then from that Hive table, we actually load into Elasticsearch. And like I said, our ETL process that is inside here, this is all of our ETL, it transforms the data so it becomes JSON documents in Elasticsearch. So all of that transformation is done at this step. We could have done that down in SQL. That's what I originally talked about, is why didn't we just do that in SQL? Why didn't we just put something in place to do that? Because we couldn't scale that. Every time we did that, it would just have to be a bigger and bigger SQL box. More and more licensing costs. By doing it this way, we can scale this as far as we want, and we can just keep moving it faster. Okay? Questions?
So you're really just using Hadoop to back up your database?
Using Hadoop, say that again for me.
To back up your database and make it scalable?
We're using Hadoop to back up our database and make it scalable. No. Okay. So the reason is my Hadoop cluster, as I mentioned originally, we only had about 2 terabytes worth of data. My Hadoop cluster at any time probably doesn't hold more than 500 gigs, because all it's doing is the last increment I gave it. So it's not even holding all of my data. It's only holding the increment. We are using Hadoop as a batch processor to process our ETL. That is what we are using Hadoop for. Yes, sir?
That leads into my question is, can you give an example of the ETL transforms that you actually are doing with your data?
So our ETL transforms, the question is what are our ETL transforms doing? Ours are actually very simple. We actually map our data down to numbers essentially for most of our stuff. So we do a little bit of ETL right here. We get it into two tables, map and data, and then we migrate those, we put those together inside the ETL process. We put those together and we flip it to a key value pair system that Elasticsearch is happy with. So that whole flipping, that key value pair is all done inside here. So when a lot of people say ETL, what do they think of? They think of extract, transform, load. They think, oh, you're changing columns and you're looking up this data and you're doing all these other pieces that go along with it. We're not. We're just flipping our data to the way that works for this, and then we're using it there.
And are you doing that through the query language of Hive, or how are you making those transfers?
Yes, so the question was, are we using HiveQL, which is the query language of Hive, to do that? Yes, we are. And that's why I said HiveQL. It took me, I wrote the ETL, this part, in SQL. I did this work actually in SQL, and then I copy and pasted it into Hive. It took me about 2 weeks to get the syntax right, and I was done. So, and I mean literally, Management Studio, copy, paste, Hive, move a few things around, and it works. So it's that similar in how it does it, how it does the queries. If you're a MySQL person, it's even easier because, like I said, semicolons killed me. That's just me. Well, and if you used the web interface Hue a year and a half ago, that thing was a nightmare. I mean, they just had so many bugs in it. I definitely suggest now you'd be fine with Hortonworks 2.0 or Cloudera 2.0, but the old versions of Hue were terrible, just terrible. Okay, other questions? Yes, sir.
Really basic question. What is the relationship between Hive and Hadoop? Do they always go together? Are they different tool sets you can choose?
Okay, so the relationship between Hive and Hadoop. So let me give you some quick background on what Hadoop really is. Hadoop is the HDFS file system. And the HDFS file system is a distributed file system, meaning it takes whatever data you give it, breaks it into little pieces, and puts it across many horizontal boxes. That's Hadoop. Okay, that really is Hadoop. Hive, or Impala, or Tez, or every other technology you can come up with sits on top of that. And what Hive does is it runs MapReduce queries for you, then produces an output. And that output becomes a table that you can query.
So you can't use Hadoop without a tool like Hive?
No, you can. Oh, yes, you absolutely can. So can you use can you use Hadoop without Hive? So 6 or 7 years ago, when Hadoop really came out, a long time ago in Yahoo World and everything else, they wrote their own MapReduce queries. Now, MapReduce queries are not simple to write. They're very not simple to write. And back then, they didn't have these tools, and that's when they wrote directly against the HDFS file system. But the reason big data is using Hadoop so much more is there are tools like Hive and Tez and Impala that make it so much easier. That's why so many more people are adopting it. And everything they're doing is trying to get more and more of those easy tools on top of it. Did that answer your question?
Yeah, I've got a bunch more, but I'll let this jump.
Okay, yes, Mark.
Do you hand Hadoop files or do you hand Hadoop structured data?
So the question is, do I hand them files? Do I hand Hadoop files or I hand them structured data? I don't want to say it's both, but in other words, the sqoop command is pulling a query that is structured data and pushing it directly in to HDFS, and then it separates it out. I do not tell it how to separate it out. I let HDFS do that work. And the sqoop command then immediately turns it into a Hive table. So if you actually read through that giant verbose thing, you would see two statements. You'd see one that puts the file on the file system. You would see a whole nother statement that map reduces it into a table. So they're one-step process, but yeah, it's hard for me to say that I don't do that because it does, but it obfuscates it for me. Sqoop takes care of that, yes.
Quick clarification on that. So could you use Hadoop as open source S3 for just raw file storage, or is that not its intended purpose?
Oh no, so okay, the question is, can you use Hadoop for open source S3? Absolutely. I believe that Hadoop is the best cheap file storage system. If you want to hold 20 terabytes of data and not worry about it being lost, and it just sits out there for time, Hadoop's perfect. I mean, that's what it was designed for. Because you've got tons of boxes, or even 5 boxes, you've got tons of drives, and they cost next to nothing. I mean, and there's no licensing costs. Again, 20 terabytes that we have inside our Hadoop system is 3 boxes. 3 boxes with 8 drives each, I think, and that's it. So it's definitely huge, cheap storage, perfect for it. And when you hear people talk about data lakes, that's what they're using Hadoop for. And that's where you made the statement, put it all in there now and process later. If you have thousands of files sitting in Hadoop and later you come along and, oh, I learned Spark. Well, Spark can use Hadoop as its source. And so all it does is say, okay, I'm going to write MapReduce and I'm going to get that data out and I'm going to use Spark against it. Then it's blazing fast. So yes, absolutely best large storage system. Okay, other question. Oh, right here.
So you just mentioned Spark. So do you think Spark could be a better alternative to this architecture?
So do I think Spark can be a better alternative to this architecture? So little thing about us and our company. I like to question the status quo. My favorite question right now is, what is our system of record? We are working on trying to replace our relational database and remove it from our system entirely. So that's hard for a lot of people to grasp, that you would not have any relational database, but we want to. One of the big technologies we're looking at to not necessarily replace this, but replace this whole process with a streaming process would be Spark. So yes, we are looking at Spark very closely. We've been talking about it a lot to put it in place to do some of these things. Our version next of this will be a streaming model. This is a batch model. So this is great for batch processing, but we are moving to a streaming model. And yes, and in a year and a half, by the end of the year, we'll probably have a streaming model. And I'll come and present next year on that one. Okay? What? Oh, no, that's the point though. See, Hadoop is still in the model. There's no question. Because again, when you talk about over here, and if you did any batch processing or loading of files, Hadoop is the perfect place to land them. Perfect place to land them. And then put them into your streaming model. So you use things like Kafka for a queue to move those things forward. I saw another question earlier. Yes? So the question is why not move our process more frequently than 1 hour? 1 hour is what our customers need and what the business requires, so we stuck with that. We have pushed it faster than that at different times when we need to. It's just a matter of what the customer need is. No, it's not a limitation, and if we wanted to start speeding it up more, we would add more memory here, and then we would add more boxes here, and we've already added a lot more boxes here. So yeah, it's absolutely a possibility. It's what met the business needs. No reason to do more if you don't have to sometimes. The reason we're looking at streaming is actually it's more about not just collecting in real time per se, it's more about having a lot more trigger points of analyzing data as it comes across. So we're not even, when we say streaming, I don't mean that it's going to be there a millisecond after you do it or after that action. It still could take a couple minutes. But the point is that it's a process that you can check everything as it's done at the time. It's not just real time. Does that make sense? That's why we're looking at that. We have a lot more need lately to process data as it comes through the pipeline instead of just in batches like this. Okay, other questions? Oh, I couldn't have answered all of them.
Can you talk a little bit about your process of taking data from Hive to ElasticSearch?
From Hive to Elasticsearch, excellent question. So our process from Hive to Elasticsearch, you see right here we have this little load ES, custom Java, and I put DLL on accident, it's a jar file. The custom process, there are now connectors from Elasticsearch that could use Hive tables directly. So we made a Hive external table, but then we wrote software here that does this. It's actually on GitHub, it's open source. The gentleman that wrote it is walking around the building right now. And all it really does is tell it to put the data inside Elasticsearch. Those connectors exist now. They did not a year and a half ago when we started the process. But basically what we do is we put it to an external table. We say, run the jar on it, and it runs the files and puts them into Elasticsearch. So it's not, again, it's kind of a simple CRUD operation. It's not a ton of business logic in it or anything. It's just getting it in there. Yes, sir.
ElasticSearch is a reporting tool, a visual dashboard kind of tool. What is Elasticsearch?
So ElasticSearch, that's a good question. Excellent question. ElasticSearch is a search engine, essentially, based on the Lucene engine. It's very similar, comparable to a Solr. It's actually, Solr and Elasticsearch were almost the same thing, and they branched and separated. Interesting, too, if you really want to find out, their table is right down the hall, the Elastic table. But basically, it's a search engine that searches documents. We put everything into a JSON document. We give the structure of what the JSON document is, and then we write queries against it to search those documents. The search queries in this is basically about, usually about 500-600 milliseconds. In SQL, it's 5 minutes. So there's a big difference between them. Elasticsearch is horizontally distributed. So you have an index that lives on multiple nodes by shards. So you have lots and lots of shards that live on multiple pieces of physical hardware.
Is it equivalent to dimensional modeling or star schemas or snowflake schemas?
Absolutely not. So the question was, is it equivalent to a dimensional or star schema? No. This is entirely JSON documents and nothing else. So this is just a raw JSON document that it searches through very quickly. So it really, you could say it was schema-less, but that's not true because the JSON document does have a document schema inside it, but it's our schema that we created, and that's what it uses. So yeah, and like I said, if you want to find more, so a lot of people, I probably didn't say that, we have a tool on the outside of this that builds dashboards. We built that tool all ourselves. That is all custom code that we wrote that calls a service that queries this and returns data.
Okay, that's the piece I was trying to visualize.
Yeah, the end result, the end reporting tool, it belongs to us. It's a web page that we built ourselves. But yeah, if you want to find more about these guys, they're just down the hall.
And what kind of data do you capture in your transactional database? What data types are you storing?
Pretty much, what data types are we storing? So we store survey data. So what we do is you can build your own survey. I'll use JetBlue as an example, former customer of ours. That you would fly on the plane and you got sent a survey and they ask you some questions. How was your experience? Did you like it? Blah, blah, blah. There's probably only 5 or 6 questions on there. Well, that doesn't tell them too much about what the plane or anything else. So from those 5 or 6 questions, they send us 200 plus columns more of data. They send us the flights, the flight time, was it late, the weather, the type of plane, the seat the person was in, all of that information. Then we can combine that all together and to say every time someone flies on flight 720 on seat B or 5B, they hate it. They give us a bad score. And so we know that seat has a problem. So that's the kind of data we're getting, and that's what's happening back here when it comes back to here.
So do you have hundreds of users hitting your transactional database concurrently that you have to worry about security and data integrity, or is it just mainly storing these surveys?
Well, right now, so this is the new system where everything in this dashboard product uses this. The old system is still in use minorly, I would say, and that system still has people hitting it as well that query SQL Server. But the goal is that no one in the future will query SQL Server. The goal in the future is really to remove SQL Server from the picture entirely and have data come from where we collected it, where we got the data, and go straight through this process and end up in Elasticsearch. Other questions? Yes, sir.
How does the indexing Elasticsearch work?
Well, are you asking how the indexing in Elasticsearch works, or how do we use it?
You said that you had way too many indexes.
We have a lot of indexes. The way that we have designed our platform is that we're a SaaS-based company, so every customer has its own database, every customer has its own index. So every customer we have has one index. That one index can have many, many shards behind it. Whatever we choose, we can choose how far to shard it out across itself. And then you have however many nodes you have inside Elasticsearch that it crosses those computers. Yes, sir?
Why not index the indexes?
Why not index the indexes? You have to bring that up from your presentation this morning, don't you? Why not index the indexes? So there's been discussion about that. The big discussion, though, more is of a pre-processing nature. Why not we just get into a pre-processing idea? But I will suggest, if you're looking at indexing the indexes, Druid, you should talk to Druid. Druid is an idea to do that same sort of thing. But yes, that is, yeah, we didn't go that far, but it could happen. All right, other questions? Well, I'm pretty close on time. I've still got a few minutes. I know John wanted me to end somewhat early so we could get back over here, but I am more than happy to end too. If you're done, you're more than welcome to leave. Like I said, I leave this open for any more questions. Let me go to that actual slide.
Another question, what would be a good place to get additional resources and tutorials about?
Right there. I usually get to this slide. You have homework. This is your homework. Again, I cannot speak highly enough about Hortonworks. They not only give you a sandbox, but they give you tutorials right there on the page. And even in the sandbox, you have tutorials. I can't stress this enough. Go there, download their stuff, start playing with it. But do a use case. You know, play with their stuff, but then get your own data. Get a file, get a SQL table. I mean, I can connect. When I go to work, I can connect from that virtual machine to my SQL database and pull something over that's real, that's mine, that I know. It's not some fake table. Use your data because then you understand it better. So, but absolutely right here, again, the slides are up on Joined In, so you don't really have to download, I mean, you don't have to take a picture or anything like that. Just go and pull down the slides, this is there. So yeah, and this goes out to the feedback. If you have any feedback, I love feedback. I'd love to hear what you say. Otherwise, I'll call it complete. I'll be done, but if you want to come talk to me, I have more than enough time. Thank you.